Hello, in this video we're going to look at a couple of trickier examples. They're not really much more complex than the other ones, they're just a couple of extra steps to take into account. So we've started off with 3 tan 2x equals root 3, and it might be worth you pausing for a moment and asking yourself, what makes this problem different from the other two examples we looked at in the previous video? Did you notice that we're using tan for the first time? That does not make it trickier. That's okay. Using tan is fine. We've still got an information booklet, and in our information booklet, it gives us values for tans. That's fine. Now, what makes it different is that we've got 2x here. And how does that make a change to it? Well, just briefly, if you remember what changing the input to our function does, in this case, because we've got 2x here, it means we're going to be going through our values twice as fast, which means the period of the function is shortened. So it is going to have a change. It is going to make a change to how many solutions we've got. But in terms of how that goes in practice, just follow through with me. Step one is as we have done in previous occasions, and that is we need to get this so that we've got the trig function on the left and a value on the right. And we can do that by dividing both sides by 3. That would leave me with tan of 2x on the right, and that would have root 3 on 3 on the left, tan 2x, and root 3 on 3 on the right. That's okay. Root 3 on 3 is one of the values we know about, but before we go any further, we are going to simplify our problem by replacing the 2x with a single variable. Now, if it says x in here, we can use theta. Here we go. So we're going to let theta equal 2x. That gives us tan of theta equaling root 3 on 3. Why bother doing that? Here is the trick. We look at our previous domain, which is x between 0 and pi, and because theta equals 2x, we are now going to have theta between, and we are going to multiply the endpoints here by this value 2 as well. 0 times 2 is 0, 2 times pi is 2 pi. So if this was 3x, that would be between 0 and 3 pi. If this was a half x, that would be between 0 and pi on 2, and so on. So we change the boundary points by considering this swap that we're doing. Now we can solve the problem just like we have in the past using this. And then there's another little bit at the end to do. So first of all, tan of theta hat is equal to root 3 on 3. There's no need to change this. There's no sign to get rid of, but nevertheless, we look at it anyway, which means that theta hat is equal to, now you can't see this, but I'm looking at my information sheet. I'm looking for root 3 on 3, and I see that it's pi on 6. So I'm going to write down pi on 6 because I can see that I'm working in radians anyway. So theta hat equals pi on 6. Okay, that's that bit done. Now I'm going to work out the quadrants. For tan, let me see now. I've got tan of theta is positive root 3 on 3, so I'm looking at where is tan positive. Tan is positive in this region and this region, or quadrants. So that's that done. Now I'm going to draw out my axes with my endpoints. I can see now I'm not going from 0 to pi, I'm going from 0 to 2 pi. So that will mean all 4 of these quadrants from 0 to 2 pi, because 0 to 2 pi looks like that, from 0 to 2 pi. So that means one of my unit lines will be in here. Oops. And then from 0 to 2 pi, my other unit line will be here. So I've got this angle, and I've got this angle, and I know that in here, it's getting really hard to draw. In here, we've got pi on 6, and in here, I've got pi on 6. So I've got theta equaling, let me see, going from smallest to largest, pi on 6. So my reference or base angle is the same as the actual angle, but also I've got this one here, which is going to be all the way to pi, and pi is 6 pi on 6 plus another pi on 6. So my second solution is 7 pi on 6. But here comes the final line to make it, to finish it off. I'm not interested in theta, I'm interested in x. So that equals 2x. Where did I get the 2x from? Well, theta equals 2x. Theta equals these two values, which means that 2x equals these two values. So I want x, so I'm going to have to divide everything through by 2. So that would give me pi on 12 and 7 pi on 12. Now, if you don't understand how this bit worked, that x equals these two values, it's probably more of a problem with your fractions. I'll spell out just one of them so you can sort of see it. So 2x equals pi on 6 is one of the solutions. So in this case, I'm going to multiply both sides by a half. So a half times 2 is 1, so I'm left with x is pi on 6 times by a half, multiply the tops, multiply the bottoms. That's how it works. You really need to be across your fraction work in this unit, as you can see. So the two solutions are pi on 12 and 7 pi on 12. And you can see that these two numbers, I hope you can see, these two numbers actually are between the original domain here of 0 and pi. So it does work. This system does work. I really do encourage you to follow through my system because I think it's the easiest way to solve these problems. I have seen other ways. The textbook has other ways, but I think this is the easiest way of doing it. Let's have a look at example 4, and then we're done. You could actually stop the video here if you think you've got a handle on it and just try them, because what makes this difficult is that it's long. So there's the end of the actual instructional video on how to deal with these more complicated problems. I'm going to zip through this one, so hang on to your seats. Here we go. First things first. We don't need to change the value, we don't need to rearrange the function or the equation because it's already just a cosine of something on the left-hand side. So I'm going to get straight into it by doing the substitution. Let theta equal 3x. So we're going to have cos of theta is equal to negative root 2 on 2. And I'm going to multiply the endpoints by 3 so that I've now got minus 3 pi is between, theta is between minus 3 pi and 3 pi. That's quite a lot of work here. So this is where it's going to get long. But next step is as usual, consider theta hat. Theta hat is root 2 on 2, which means that theta hat, again, looking at your information sheet, will show you that theta hat is equal to pi on 4. So there's my reference or my base angle. My theta hat is pi on 4. Now, here's where it gets tricky. First bit starts the same. I'm just going to consider cosine is negative. So where is cosine negative? It's negative in this region and this region. So that's what I need to aim for. Now I'm going to split up my graph into my negatives and to my positives. And you can see I'm going to have quite a few here. I've got negative 3 pi to 3 pi. So I'm going to deal with the negatives first. You've got from 0 to negative 2 pi. So there's 1. And then I'm going to have from negative 2 pi, to negative 3 pi. And then not beyond that. So I can sort of shade this bit out. So again, this is 0. We're going in the negative direction, so we're going backwards. 0 to negative 2 pi. And then I pick up here, negative pi to negative 3 pi. So this will give me some good regions to work with. And then I'm going to do the same thing positively. So I've got 0 to 2 pi. That's this one. And then I've got from 2 pi to 3 pi. So 0 to 3 pi. And I'm not going beyond 3 pi, so I can erase this as well. So there's my 4 possible regions. So again, I've just split up my domain here into bite-sized pieces so I can figure out how this ties into the whole lot. So now I can just look at each diagram in turn. In this diagram, what works? Well, this works. Hang on, we're going backwards, sorry. So we've got this works. And then, I've got another one, haven't I? I've got another one over here. So I'm going to have to draw another diagram out, which is getting a bit messy. I didn't mean for it to be this messy, but that's okay. And I'm going to have between 0 and negative 2 pi. I'm also going to, actually stuffed that up. It should have been here because I'm looking for these two regions. or I've got here. So these are my two possibilities for 0 to negative 2 pi. So it's this angle or this angle. Next one along is between negative 2 pi and 3 pi, and that is just this one here. I don't have to consider this one because it's beyond negative 3 pi. This one is the next one. This is going in this direction now. So where cosine is negative is here. And I'm going to have to draw another one now because I forgot about that one as well. So from 0 to 2 pi, this is also a solution, which is from there to there. And then finally, I've got this one here, which is again going in a clockwise direction. So 0 to 2 pi, and then that should say 2 pi. 2 pi to 3 pi. I've got one more solution here. So you can see there's quite a few solutions here. There's 1, 2, 3, 4, 5, 6 solutions. So now I just need to work out what they are. So I've got my theta hat in here all the way along. That's pi on 4. All my theta hats. All of my theta hats, always between the x-axis and the unit line. And just so I don't get confused, I'm going to change colors and I'm just going to put in my angles as well. So this one here is this angle here. And then I've got this angle here. And then I've got this angle here. Then I've got this angle here, now going in the positive direction, this angle here in a positive direction, and this angle here in a positive direction. All of those angles. Putting in those arcs with the arrows on them helps me make it really clear where I'm going with these problems. Okay, here we go. What does that mean? Theta is equal to, I'm just going to have to name them all off. Doesn't really matter if they're not in order. I think I'll use the last line to get them into order. So I'll just go through them via diagrams. So here is between 0 and negative 2 pi. So I'm going to go all the way up to negative pi, and then I'm going to add on, because I'm going in the opposite direction, pi on 4. So I've got negative 4 pi on 4 plus pi on 4 is going to be negative 3 pi on 4 is one solution. Next one is this one here. This one, oh no, I'll at least do all the negatives to start off with. This one here is between negative 2 pi and negative 3 pi. So it's going to be negative 3 pi all the way up to here, and then backwards pi on 4. So what's negative 3 pi? Negative 3 pi is negative 12 pi on 4, plus pi on 4 is negative 11 pi on 4. Next one, there's a negative over here as well that I did out of order. So this one here is between 0 and negative 2 pi. So I've gone to negative pi. Then I've gone another negative pi on 4. So I've got negative 4 pi on 4 minus another pi on 4 is negative 5 pi on 4. Next one. That's all the negatives done. Where's the positives? This one here is between 0 and 2 pi. And so we've got all the way to pi, which is 4 pi on 4, minus pi on 4 is 3 pi on 4. This next one is down here. And I'm going to go all the way to pi, which is 4 pi on 4, plus another pi on 4, which is 5 pi on 4. And then my last one is, let me see, what did I do? Oh, between 2 pi and 3 pi here. So I've gone all the way to 3 pi, which is 12 pi on 4, back a pi on 4. So I've got 11 pi on 4. Now, you might notice that these are 3, 11, and 5 with negatives, and then 3, 11, and 5 with positives. That's just a coincidence because pi on 4 is right in the middle. They don't always work out like this. just the positive and negative variance of each other. So it's better to just do it all out. Remembering that that's equal to 2x, which means that x is equal to, so I'm just going to divide everything by 2. I'm going to put them into smallest to highest as well. So the smallest here is minus 11 pi on 4. So when I divide that by 2, I'm going to get minus 11 pi on 8. So I'm going to go minus 11 pi on 8. And then I've got minus 5 pi on 8. That's that one here. Then I'm going to go minus 3 pi on 8. Then I'm going to go 3 pi on 8, 5 pi on 8, and 11 pi on 8. And that's my final solution. I know it looks more complicated, but it's just that there are quite a few more moving bits in this particular problem here. But it's really just a longer version of example 3 that I just did. So yes, it is longer, but it's more complicated. Okay, that's a long enough video for this one. Have a go at doing some problems from the textbook.